again, I love this session because it just thinking about, imagining what's possible. And I think with your, global experience and, you basically have spent your lifetime, right, in the agriculture industry, right? So what you're envisioning, I think, should speak to a lot of people in the industry, right? So the title of this show is called RoAI, so we have to talk about return, right? So I guess the question in this context will be, if somebody with the required resources, they followed your advice, right? They designed a beautiful farm in this fashion. And what returns would you anticipate, right? Both quantitatively and qualitatively?
It is hard to speculate, but let me try to use some fundamental things we know. So we know that the best farms in a system, be it a whatever type of farm system, with lots of farmers within that system, or lots of farm units within the system, the best farms are at least 10% ahead of the worst farms. And sometimes you hear numbers which are even more unbelievable, but I mean, I believe them, but they're hard to believe, that you can see differences of up to 30%. You certainly see that in milk production. You certainly see dairy farms that completely outperform other dairy farms. But, the 10% number is not a bad number if we think about crop production for corn or beans. That typically happens. If you run a research center, again, you can run way above what you see in the field. And my interpretation of that typically, Jeff, would be that greater care, smaller unit size, more people taking care of per unit. Now, people are not that great at taking care, but I mean, they're doing a better job than if they're not there. But clearly, if we move towards robotics, we'll be much more accurate in that. We're quite inaccurate in our use of water. So I think the ability to use sensors in the soil and detect in real time the uptake of water by the plant's roots will allow us to also know where to irrigate, when to irrigate, and how much is actually required. We have traditionally used NPK, nitrogen, phosphorus, and potassium as being our fertilizer. We're increasingly looking at other microminerals, but we can get into things like chromium, selenium, boron. Obviously, we've already been working with copper and zinc and manganese and magnesium. And you can imagine what else could be done, because as we understand more precisely the plant's needs, the animal's needs, these things, I do believe that we have very little information on what happens in agriculture in real time. But clearly, as we get more of that precise information, milk being a very easy example, because we milk cows several times a day. With robots, they milk themselves. So that's kind of interesting.
Yeah.
So that is the opportunity in milk to start looking at how do we take the components of that milk and see what the animal's health is, what the animal's welfare is, how good her nutrition is, her ability and readiness to, get to become pregnant again. All of these things are informations that today we just simply don't have. And we haven't, I'm very focused, as you can tell, very much on agriculture. I haven't talked at all about what happens at human level.
That's right.
If these foods are changed because the animal is healthier, because the animal has been fed better, if the crops we get through multi-cropping could not be maybe multi-cropped, but we could put, monocropping, we could multi-crop, we could put multiple crops in the same field, we could put trees, and we could put animals, and we could put different plants and flowers, etc., etc. So in my imagination, I think the 30% is a minimum. We could be seeing improvements. I mean, we could be doubling the productivity of what we do today.